Now we will briefly talk about image segmentation. We will not look into the details of how segmentation is done, but we will introduce the idea of image segmentation. Segmentation is the process of breaking an image into regions of similar pixels, that is, pixels that have same brightness, same color, and same texture. Now there are two approaches to segmentation. Say we are given a picture like this and we would like to segment this image. We already know how to detect edges in an image, and we can even classify edges by their intensities, and we can come up with a picture that looks like this, where the edges are correctly detected. Darker lines represent edges that have very strong, the derivative, and lighter lines represent the edges that have lower intensity of edge. So then we can, taking these edges as input, we can combine some of the detected pieces of the image or smaller segments of the image into larger segments, and this can help us come up with something more meaningful, such as this one. And we can apply additional algorithms to further come up with image segmented images like these, which can be much more meaningful to understand what objects are present in the scene and so on. The next approach is to directly detect regions themselves. So in other words, take this image as input and build a method that can directly produce an output like this. So these is these days achieved using deep learning. Deep learning methods are capable of taking an image like this and skipping all of these edge detection and all of these intermediate steps and directly produce these like a segmented image. Of course, in principle, they do a lot of these inside, but we do not need to manually control edge detection and many other things in the middle. Let's look at some applications of edge detection. One application of edge detection can be something like counting the number of leaves in plants. Say, for example, in a plant research facility, the researchers are looking at how fast a plant grows, how many leaves a plant has, and let's say there are cameras installed to take a look at the plant's growth. So with image segmentation, we can take pictures like these as input and then sort of train a model to correctly train a filter to correctly detect the edges in the picture, something like this, and then we can just process these detected edges to come up with various ways in which we can count how many leaves the plant may have. For example, this picture will clearly have 2 leaves. This picture will be slightly challenging to find out how many leaves it has, and something like this will give you more number of leaves in the plant. So it's not an extremely easy task, but a task that's a good fit to apply image segmentation algorithms. Now, moving to problems like detecting pedestrians in a scene, where what we would like to consider is maybe one person in an image could be one segment, right? So we could define each person as a segment in an image, and what we would like to do is use the algorithms to the AI methods to classify or recognize these segments in an image. So this brings us to the topic of what exactly are segments. Earlier we discussed that segmentation is a group of pixels based on similar color, brightness, and texture, right? But in case of pedestrians, we see that a pedestrian, within the segment of the pedestrian, we may observe many colors, many brightness levels, and many textures, right? So our definition of segment, that is how we define a segment, has evolved over time. Earlier, because we couldn't do these complex image segmentations, we defined segmentation as something very basic like this one. But nowadays, because with the help of deep learning, since we can do much more complex tasks, we define segments. We also define segments as these really complex segments of objects in the scene. What we see is that our original definition of defining segmentation based purely on low-level attributes, that is, these low-level properties such as brightness and color, I mean, such a definition cannot be expected to deliver final correct boundaries of all objects, because each object may have multiple brightness levels, multiple colors, and so on. So to reliably find object boundaries, we need high level knowledge of the kinds of objects in the scene. In other words, the algorithm that detects segments also needs to understand what objects are present in the scene, right? So if the method that we develop had some idea about the objects in the scene, then it can do a better job in doing the segmentation. And representing this knowledge, that is representing what objects are in the scene and how to correctly segment them, is an active area of research. However, these days deep learning has been very successful at taking images as input and classifying, or creating segmentations of this image. Here's an example of a successful work by Facebook AI research group. So Facebook AI research group in 2018 came up with a method known as mask RCN, and there are many other similar methods, successful methods for image segmentation. But here's an example. So their method can very accurately detect objects with multiple, low-level features. For example, here they have detected a car with a very high confidence of 90%, another car with a confidence of 72%, right? They have also detected pedestrians, traffic light with some confidence, car again with 93.7% confidence, and so on. So now image segmentation methods have become really powerful, where they can take things like this scene as input and sort of detect segments in the image.